In this video, I want to demonstrate how to use technology, in particular StatCrunch, to perform a hypothesis test for population proportion. So we're looking at this exercise from Chapter 10 in your text, and I'm just going to open it up in a different program here so I can write over it. We have an organization surveyed 1,034 adults in a certain country that are over 18 and found that 538 of them believe that they could not have enough money to live comfortably in retirement. So the question is, does this sample give us evidence that a majority of adults in this country believe they will not have enough money? So the organization only surveyed 1,034 adults from a particular country, implying that this is just a sample. They say the word sample again here, and they're asking about a majority. Now, majority means that the proportion or the percentage is over 50%. So that's how I know that this is a proportion test, because the question is about a percentage or a proportion. So as you look at these exercises in MyStatLab, some of them will have slightly variations on parts, but they will generally ask you for the main components of a hypothesis test. You can see here that in MyStatCrunch they're asking, or I'm sorry, in StatLab they're asking you first for the hypotheses. And so generally in a test for a proportion, test about the proportion, the steps are going to be as follows. List the hypotheses, and then calculate the test statistic. For proportion, this is going to be z sub 0. Then find the p-value, so we're using the p-value approach here. There's another video explaining the critical value approach. You're not required to use that approach, but you should be familiar with the ideas behind it. So find state the hypotheses, find the test statistic, find the p-value, which is a probability, and then make your conclusion. So here we're asked about whether or not a majority of the people believe they will not have enough money. So just switching up here a little bit. Our null hypothesis will be that the proportion is at that 50% mark, so that we can test against it. The alternative hypothesis then, that the proportion is greater than 50%, which of course I should write as 0.5 instead of 50%. Your text, your MyStatLab is going to want you to write that in decimal form. So the null hypothesis is that the proportion is equal to 0.5, and then the alternative hypothesis, H1, or sometimes written as HA, is that the proportion is greater than 0.5, more than 50%, so that would be our majority here. So we want to assess the evidence for this alternative hypothesis. So the way that all statistical tests of hypotheses work is we assume the null hypothesis is true, and then we measure the sample evidence against it. And that's what the test statistic measures. So the test statistic is going to look at the sample proportion compared to the claimed value of the population proportion in the null hypothesis here, 0.5. So you can use the formulas. Again, as I said in this video, we're going to primarily use StatCrunch, but if you do want to use formulas here, the formula for the test statistic would be p hat minus p0 over the square root of p0 times 1 minus p0 over n. So you can go ahead and calculate that yourself if you want. P hat is, of course, the sample proportion, so that would be the 538 people who believe they don't have enough money compared to the sample size of 1,034. We can calculate that, compare it to 0.5. And then what we do essentially is just look at the value of this test statistic. It's a z-score, so this sample proportion is how many standard deviations away from this claimed value of 0.5. And then the p-value, since this is a right-tailed test, is going to measure the probability. This is a normal distribution, so it's going to assume the center is 0.5, and then it's going to look at our sample proportion, which we'll calculate here in a second, which is probably greater than 0.5, otherwise we wouldn't be doing a right-tailed test. And so to look at the value of p hat and the likelihood of a sample proportion larger than that, to the right, because it's a right-tailed test. And so then it'll give us that probability. If that probability is small, then we have evidence that perhaps the center of this distribution is really not 0.5, that the null hypothesis is false, and we have evidence that perhaps the alternative is true. And that's why the general rule is reject the null hypothesis if the p-value is less than alpha. And so that's the question really here. Is this less than alpha at the level of significance. And that's what we're going to base our conclusion on. So we're going to do this in StatCrunch. So a couple numbers that you need in StatCrunch are going to be the sample statistics, the 538 people that believe they don't have enough money, and the 1,034, which is our sample size. So I'm going to go ahead, and you can get to StatCrunch directly through your exercises in my stat lab. So I'm going to go ahead and I'm going to go back to my stat lab, and in the question help I can go directly to StatCrunch, and it should open a StatCrunch, a blank spreadsheet here, and I go to Stat, Proportion Stats. Remember, this is a test about a proportion, one sample, because I only have one group of individuals being studied, and one population that I'm concerned with. We have summary statistics here. We don't have data. Data would be like a list of people that said, yes, I believe, no, I don't believe, so I go to with summary. The number of successes is the number of people that have the characteristic that you're concerned with. So in that case, oh, look at me, I went ahead and I forgot the number already. In that case, our case, that would be the 538, and so the 538 is the number of people that would be considered a success in this case, so I'm going to put 538 there. And then the number of observations is our sample size, 1,034. We're performing a hypothesis test. Confidence intervals was the last chapter. The null and alternative hypothesis here, that's what those symbols stand for. Notice that they're both about proportions. Equals 0.5, that's the default, just happens to be the proportion we're concerned with here. So we would put in 0.5 there, and then we need to change this to a right-tailed test. Our alternative should be p greater than 0.5. And then I don't have to put anything else, I just go ahead and hit compute. And so this is going to give me everything that I need here. My hypotheses, I'm reminded of what I put in there as a quick check. I make sure that I put in my counts correctly. And here's my sample proportion. This is just the standard error or standard deviation of the sample proportion. So sample proportion, this is our p-hat here. And then our z-stat is our test statistic, and this is our p-value. So our sample proportion is 0.52. And so that's our p-hat. So our p-hat here is 0.52, so you can see that our sample proportion is a little bit bigger than 50%. And then, so how many standard deviations away from the mean is that? Well, that's our z-stat. So I'm going to go back to StatCrunch and get my z-stat again. So our z-stat was 1.306. I think they want that in your, my math lab to 2 decimal places, so we'll call that 1.31. So 1.31 is our test statistic. That means that 52% is 1.31 standard deviations above 50%. So it's a little bit more than one typical jump away based on our sample size. And so from that we measure the p-value, so that would be the probability that a normal distribution value is greater than 1.31. So just quickly going back to StatCrunch here, our p-value in our output is 0.0958. 0.0958. 0.0958 is our p-value, so I'm going to go ahead and jot that down. You're going to have to enter that into StatCrunch. So our p-value is 0.0958, so that's this area right here is 0.0958. And so then for our conclusion, the question becomes, is the p-value less than alpha? Is the p-value less than alpha? So we're comparing 0.0958 to our alpha level that was given in the problem here as 0.01. That's a pretty small level of significance. That's about 1% compared to 9.58%. So certainly the question of is it smaller here is no. So we do not reject the null hypothesis. And we say that there is not enough evidence to justify a conclusion with the alternative. There's not enough evidence that p is greater than 0.5, which means that there's not enough evidence that a majority exists because the p-value is too big. And so that's an example of using StatCrunch to find the components of a hypothesis test. Your hypotheses you should get right from the problem itself. StatCrunch, you're just going to enter those into StatCrunch so they calculate the p-value correctly. StatCrunch will give you your sample proportion, it will give you your test statistic, and it will also give you your p-value. And then it's up to you to put all of that together to make a conclusion. And so you'll see a mix of problems in Chapter 10, some about tests about a proportion, some with tests about a mean. So your job is to know sort of when you go into StatCrunch, which test are you performing. So if you can tell that it's about a proportion, you go into proportion stats in StatCrunch and then pull out the numbers you need and make the appropriate conclusion. Statisticians do this kind of stuff all the time. Very rarely do we calculate anything by hand. So knowing how to use the technology, knowing what types of analysis to run in the computer is a major component to performing statistics out there in the real world. Hope this video helped. Email if you have questions.